Hey guys, welcome back to part 2 of Intro to Trig lesson. In the last lesson we talked about what trig ratios are and the relationships that those ratios have with a right triangle, okay? And we said that an easy way to remember the trig ratios, we can use SOHCAHTOA. So just as a nice little quick review, the first letter tells me the name of the ratio. The second two letters tell me the side lengths that go with that ratio. So for S is for sine, that's the opposite side with the hypotenuse. C is cosine, that's adjacent with hypotenuse. And then tangent deals with the opposite and the adjacent sides. Okay? And that's what we did. And today we're going to talk about how can we use that information. Because right now, all I have is a ratio with a name. That's not much info. Okay, so what can we do with that? So what I'm going to do is I'm going to introduce the usefulness of it, and then we're going to use that information to figure out some side lengths, okay? And then in part 3, yes, there's a part 3. I decided to add on to it. I know it's a geometry class, but I love trigonometry, so I'm going to show you how to find angle measurements with it. Aha! It kind of completes the circle with it. All right, let's look at this triangle. Now, this is a 45, 45, 90 triangle. Because we have two angles that are the same, we know it's isosceles, okay? So these two side lengths are the same. So just for an example purpose, let's make this guy 5 inches, make this guy 5 inches. And if I use Pythagorean theorem, the hypotenuse would be square root of 50. Now, I know I could reduce that. I could do some things with it, but just for this example and what I need it for, we're going to leave it as square root of 50, okay? Now, let's just go ahead and pick an angle. And there's only one that we could pick, that's right, 45. And just to make it easier to look at, let's get rid of this top one. I mean, it's going to be the same fraction no matter what, but let's just stick with this 45 degree angle. Let's say I want to find sine of 45 degrees. Now, in the past, we usually had angle A, angle B, angle C, but hey, now I have a measurement there, okay? And how's that going to work? Well, just hold on. So sine goes with opposite and hypotenuse. So the opposite side is 5. I'll put an O there for opposite. And the hypotenuse is over here, which is square root of 50. I'll put an H. So let's go ahead and write the fraction. Oh, sorry. So it's going to be 5 over square root of 50. Now, I'll write this off to the side. That looked like 50, huh? Okay. Now, here's what I'd like for you to do. And it's good to have a calculator handy for this part of the lesson. So what I'd like for you to do, okay, is grab a calculator and type in your calculator 5 divided by square root of 50, okay? I'm going to do the same thing. I'm going to grab my calculator as well and type it in. So let's see. 5 divided by square root of 50, okay? And I get 0.7071, okay? I mean, we could round, but I want to provide as many place values as possible so you can kind of compare. All right. Nothing special there. So at a 45 degree angle, if I do the ratio sine, that's the value that it comes out to be. Okay. Let's change it. New triangle. Okay. Except this time, I'm going to multiply all the side lengths by 2. So this is 10. This is 10, and this will be 2 times square root of 50, which once again, I know I could simplify it, but just for the sake of the argument, we're just going to leave it like this, okay? Let's do sine of 45 degrees again. So sine of 45 degrees equals, your opposite side is here again, right? Your hypotenuse is over there. So it's going to be 10 over 2 square roots of 50. Now, a lot of you, if you know how to reduce, you're probably thinking it's the same thing. And it should be. If you type this in your calculator, 10 divided by 2 times square root of 50, you will get 0.701. Hey, that's interesting. This is what's getting like the wheels turning with mathematicians. They're sitting there thinking, wait a minute. I have two triangles. They're different. They are similar by angle, huh? There's some similarity going on there. But they're still different, and if I do 45 degrees, I'm getting the same answer. Huh. maybe there's something going on here. Maybe I could predict what the ratio is going to be just given the angle, right? So then we could start moving on a little further. Hey, maybe let's try what side lengths can I make up with a 43-degree angle, right? And just go from there. What can I make with a 35-degree angle? Okay, what are the side lengths? What's the ratio of the side lengths going to be? So it starts creating a buzz here. And what ends up happening is we have a very useful tool to find side measurements because we know what the value is going to be already. Okay, and your calculator knows this too. It's programmed to know that. So here's what I'd like for you to do. In your calculator, let's go the reverse direction. I want you to find sine of 45 degrees in your calculator. Okay, so hit sine, type in 45 degrees. Okay, so it looks like this. There we go. Okay, so sine of 45 degrees. Hit enter, and look what happens. I get the exact same value. Okay, you don't even have to draw the triangle. Your calculator knows what that is, so it's programmed into here. You know what this was before this? Because think about it, we didn't always have calculators. It was a table. Okay, you would have your angle listed here. You would have the trig ratio listed in the other columns. Okay, just like this. And they would sit there and say, oh, this is 0.7071. Okay, and you would have to look at the table. You'd have to look through all these values. So 46, 47, 48 degrees. And continuing, it gets worse, guys. You could have done 48.1 degrees, 48.2 degrees, 48.0001 degrees, okay? So it can be pretty tedious when you're looking at tables to figure out what's the value going to be for sine, cosine, tangent. But your calculator knows that already. Okay, so you don't have to worry about that. Technology is such a great thing right now, especially for a math person, okay? It's helping us quite a bit. So that way we can focus on the concepts and a little less on the number crunching, okay? Not saying the number crunching isn't important. It is. So knowing this information, let's see if we can't figure out what a side length could be. Sound like a plan? I think it is. And remember, you are going to need a calculator that can do trig. Okay. All right. So just for practice. Okay. So using your calculator, I want you to go ahead and type in cosine of 72, sine of 30, and tangent of 70 and figure out what those ratios are going to be. Now, I know it's not going to be the fraction like we know it is over there, so we can locate the sides of the triangle. It's going to be the decimal value, but that's okay. That's all I want, okay? So pause the video and do so. I'm going to go ahead and write the answers. So for the first one, we get 0.309. This one comes out to be a half, and the last one is 2.747. Okay, so hopefully you're getting the same values when you're plugging those in. And all you're doing, okay, if you're using something like this, you're going to hit the cosine button. You're going to type 72 in, just like that, and you're going to hit enter. Okay, and that's the value you get. Okay, that's the ratio, just in decimal form. Okay? Now, if you didn't get it, that means your calculator is in radian mode. Okay? We're measuring things in degrees, not radians. Now, I'll explain what that is in another lesson video. But if that ever happens, if you have a calculator like this, if you hit mode, see how the options are up there? You got degree and radian. Make sure degree is highlighted. Okay? If it's not highlighted, then you're measuring in radians, and you're going to see, wow, wait a minute, Mr. McCall, that's not what I got, and it's true. Okay? So we'll discuss that a little bit later. Okay, so that's just practicing using the calculator. Now let's find side lengths, okay? So here's the first problem that we're going to conquer together. Okay. And I tell you what, we're going to need this. Okay, we'll put that off to the side. Now, how do I solve for E? Now, this is a right triangle. Could we use Pythagorean theorem? No, there's not enough information. So we're going to use trigonometry. Okay? Knowing what I know now as what trig can do, which is really cool, okay? What you're going to do first is locate the sides and what the relationship is to the angle that you're looking at, okay? So I'm looking at this angle in particular. I could look at this angle too, but this is what they give me. So this is 72 degrees. Now, if I go across, I see that E is one of the side lengths they give me. So that's the opposite side. I'll put a no there. And then 13 is my adjacent side. It's right next to it. Across the right angle is the hypotenuse, which, do I use the hypotenuse in this case? No, there's no value. I'm not going to even bother labeling it. What trig ratio involves the opposite and the adjacent sides? O and H. I'm sorry, O and A. What involves O and A? Tangent. That's TOA, right? Tangent involves those two. So let's write this out. Tangent of 72 degrees is going to be this ratio. O is first, so it's going to be E over the adjacent side, which is 13. Okay? That looks a little different. I got a missing part there. I got to solve for it. What I'm going to do is put 1 underneath this guy. It doesn't change anything. Do you remember what we did here? We kind of cross-multiplied, right? Or we could just multiply by 13 to be done. But just, I'm relating it to the similarity stuff we did in the past. Multiply these two guys together, and multiply these two guys together. Okay? So this is 1 times E, which is just E. And then these two, we have to be careful on how we write it. It's going to be 13 times tangent of 72 degrees. See how I put the number first? Okay? I didn't do this. I didn't write that way. Why'd I cross it out? Well, here's the deal. If you plugged in your calculator is going to multiply 72 times 13 and then take tangent of that guy. That's not good, okay? You want to make sure you're very careful with it. I mean, could you get away with this with some parentheses and stuff? Absolutely, but I just wouldn't worry about it. I'll write it like this, okay? So this is what you're going to type in your calculator. All right, so I'm going to show you right here what that looks like. So 13 times tangent of 72, okay? So that's what it is, 13 times tangent of 72, okay? And we get this guy. So it's roughly 40. Inches, feet, whatever it is. I'll put 0, 0 there. But it's roughly 40 there. Okay? Now, just to show you, okay, I typed it in the other way. Look what happened. See how it's multiplying the angle with it? And I got a different value altogether. But if I did this, okay, if I put the parentheses in, if I close it, then I do get the right answer. To me, why chance it, right? Just go ahead and write it this way. Okay? Pretty cool, huh? So we got to identify the trig ratio and then set up the problem, cross multiply, and then solve. All right? Really cool, huh? I love trigonometry. It's a lot of fun. Okay? A lot of good applications. I mean, trigonometry is like a year-long course. There's so much you could do with it. Okay. Try another example. All right? Okay. All right, we got this guy. All right, next example. That's 32 degrees. First step, the sides, right? Figure out what they are. So here's my angle. So 8 is the opposite side of that angle. So that's an O. And then across the right angle is X, which would be the hypotenuse. Okay? Now, O and H, that's this guy, which is S, right? It's sine. Sine deals with the opposite hypotenuse side. Let's go ahead and write the ratio. So it's going to be sine. We put the angle next to it. Previously, we had what? Angle A, angle B, but now we know the measurement. That's going to equal, okay, opposites first. So it's 8 over X for that guy. Okay? Now, I encourage you, pause the video if you want to try this out. This problem is a little bit different, though, okay? to put this over 1. I'm going to cross multiply again. 1 times 8, 8. Now, look at this guy. X times sine of 32. Now, how do you think we're going to write it? Just like the other problem. I put the number first, right? This one, I can do the same thing. I'm going to put the variable first, then multiply it by sine of 32 degrees. Okay? I would not do this. Wouldn't do it. It looks like the angle isn't complete. It's being multiplied by a variable, it looks like. Notation-wise, it's not proper logical math. Okay? So this is what we got. Oh, wait a minute. Is that what we did previously? I don't think so, huh? We just had to multiply and we're done. This doesn't look like that. We have an extra step. Okay? Now, I know there are letters here. But remember, this is just a number. It's some random number. Not random, I should say, but this is a number. And if I'm multiplying by some number, the opposite to undo it would be to divide by it, right? Let me give you a quick example. If I had 5 equals 10x, you would solve that by what? Division, right? Take it to the other side, x gets by itself. Right? They cancel. All I have is x. On the other side, I have my fraction. Okay? I'm going to do the same thing here. I'm going to divide both sides by sine of 32 degrees. Okay? Those guys cancel. On the other side, I got to do the same thing to keep the equation balanced. X is going to equal 8 divided by sine of 32. That's what we got to type in the calculator. So this is a division problem. Let me go ahead and do that right now. I'm going to show you what this looks like on the calculator. Okay, so here we go. So 8 divided by sine of 32. Okay, I'm going to hit the enter button. Boom. And there it is. So 15.09, we can bump it up to 15.1. So x is roughly 15.1 or 15 and a tenth. We're so used to saying point. I know it's not very proper math lingo, but we're so used to that. Okay? So that's the side length for the hypotenuse. All right? What do you think? Pretty cool stuff. It really is. And remember, it all came down to, ow, that hurt. You know, having sliding whiteboards is quite dangerous. It all came down to like this basic principle, you know, like I could see that there's a pattern emerging that sine of 45 degrees will always be this, always be that value. No matter what the triangle side lengths are, it always comes down to this. And just that little process, that concept gets a lot of ideas churning to where, okay, now we could probably do the same thing for other angle measurements. If we measure a triangle and one of the angles is 43 degrees, what kind of measurements can I make with it? And then can we use that to solve some other stuff? Okay? Because remember, Pythagorean theorem could fail here. If I don't know enough information, I can't use Pythagorean theorem to find a missing side length. Now I'm down to some trigonometry. Okay? There's other things you could do, but from what we've done in this class, that's the only other option we got. Hope you're doing well. My notes online go through a couple more examples if you want to try those out. And stay tuned for part 3, where we'll talk inverse trig functions, which we need to do to find the angle. So for instance, part 3, we're going to do this. We're going to figure out what x is. We're going to go backwards. How do we find that guy? Okay? And we'll talk about that later. Hope you're all doing well, and I'll see you in the next lesson video.